We are going to see about digital signature. Digital signature is also known as electronic signature, which can be used to authenticate the identity of the sender. It could be any message or the signature of a document. Okay, it is possible to ensure the original content of the message or the document that has been sent is unchanged. It will be remain changed till it reaches the receiver. Okay, so before going into digital signature explanation, we will just see the recap of the last session and the basic terminologies what we have seen in the last session. So some of the terminologies here. Plain text is nothing but the original message. We have seen plain text, ciphertext, right? So plain text is nothing but the original message which is given by the sender. Okay. Then ciphertext. Ciphertext is a coded message. Ciphertext is something a coded message. We found what is space. How we found from the original plain text to the ciphertext in the last session, right? So ciphertext is a coded message, and cipher is an algorithm for transforming plain text to ciphertext. When you are transforming the plain text to the ciphertext is nothing but cipher, the process of giving algorithm from transforming transforming plain text to the ciphertext. Okay. Next is a key. Info used the information which is used in the cipher knowledge which is known only to sender and the receiver. The key is the code or the OTP which we call is the information used in a cipher known only to a sender and the receiver. The next one is encrypt, encipher or encrypt. We have something called encryption and decryption, right? Encrypt, encipher, decrypt, decipher. Encrypt is covering the plain text or the ciphertext itself, and decrypt is also known as decipher, which recovering the ciphertext from the plain text. When you are recovering, it is known as decryption. When you are converting that to a plain to a ciphertext, that becomes encryption. When you are recovering those texts to the plain text, I have sent some message to you and you are recovering. When you are recovering with the help of the key, then it becomes your decipher or decrypt. Okay, so encryption and decryption is a study which is actually a branch of cryptography. Okay, cryptography is the study of encryption principles or a method. It's a method which we use to solve the key or to maintain the document with the help of security. If you are using the security with the help of network to reach your receiver, the whole process, the method which you use, the study of encryption principles or method is nothing but cryptography. Okay, we have something called cryptanalysis. That is nothing but code breaking. Is a study of principles or the method of deciphering ciphertext without knowing the key. When you are converting here, deciphering means what? Converting the ciphertext to plain text, right? So here, without the key, if you are able to access to the documents, if you are able to convert that, that becomes your code breaking. Okay, so we have cryptology. It's actually a field for both cryptography and cryptanalysis. So these first one, with help of key, when you are converting that particular study, the method which you use for encryption, that study is nothing but in cryptography. And cryptanalysis is the code breaking, which is without using a key. When you are able to decrypt the ciphertext, then it is nothing but cryptanalysis or code breaking. So this both field, when you are doing both field, that particular study is nothing but cryptology. Okay. So now we can see in depth about what is digital signature. Yeah. So digital signature is actually a part of cryptography when you are using asymmetric. Asymmetric is meant in a sense with help of key, with help of a private key. Okay, asymmetric cryptography used to stimulate the security properties of a signature in a digital rather than writing form. So if it is in a written form, it becomes a private key. If it is in a digital form, that becomes your digital signature. Okay, digital signature is a scheme which is normally in a two algorithm. One is public and private here. Okay, so both, if one for signing which is involved in users security, that becomes private. So only one person will be able to access. One to one, one to many, it becomes your public key. Okay, so the output of the signature process is nothing but digital signature. When you are utilizing in a digital format to lock your key, that becomes your digital signature. Digital signature is used to authenticate the identity of a sender of a message or a signature of a document, and possibly to ensure the original content of a message or a document can be sent in is unchanged. Okay, so the signature, digital signature, is easily transportable. It cannot be limited by someone else and can be automatically time stamped. So you will have some kind of time limit to utilize your OTPs, right? So only one person will be able to use that OTP, right? So that is easily transportable to the end users. So the ability to ensure the original signed message arrived means that the sender cannot easily repudiate its later. So we have seen three stages difference. There is the difference between electronic signature, electronic digital signature, and digitized signature. So when you are maintaining the documents with the help of your manual signature every time, and when you are locking it with it, and when you are accessing it to it, so there is three different stages: electronic signature, digital signature, and then the third one is digitized signature. When you are using that key again and again, that becomes your digitized signature. Digital signature, when you are having a locker, when you are locking any particular account with help of a private key, that becomes your digital signature. Electronic signature is when you are actually signing, when you are actually doing a signature, when you are actually creating a sign, when you are creating a signature to lock it. So next is how it works. The use of a digital signature is usually involves two purposes. One, performed by signer, another receiver. Okay, so the signature creation uses the hash results, okay, which is diverted from the unique to both the sender signed message and a given private key. Okay, so for the one who is signing, there must be only a negligent possibilities that the same digital signature will be created by the combination of other messages or a key. Okay, so the creator has to be more in terms of avoiding the negligence of digital signature, which cannot be repeated again. Okay, and then the next one is digital signature verification. So digital signature is by reference to the original message and the given public keys. So digital signatures can be created for the same message by using the private key. So there are two different types. One is creation and the verification. And there is an example which assumes that you are going to uh, send a draft of a contract. So you just go through this, and you at the end you'll be having a message to make sure that it is an intact for you, and there should be some kind of problems which will be recollected or which can be reviewed. So assume that you are going to send a draft of a contract to your lawyer in another town, and you want to give your lawyer the assurance that it was uh, unchanged from what you sent. So that is really from you. Okay, so you copy paste the contract into an email note. Second is using the simple software, you obtain a message hash of a contract. Third, you then use a private key that you are previously obtained from. The encrypted hash becomes your digital signature of the message. So there's a note that it will be different each time you message. You say whenever you're sending a message to a lawyer, that will become every time it will be changing. Why? Because of your encrypted hash becomes your digital signature of a message. Okay, your lawyer has used the public key to encrypt the message. Okay, if the hashes match and the received message is valid. Okay, then see, here is the note. At the other end, your lawyer receives the message. Make sure that intact from you, and your lawyer makes the hash of your received message. So when you are sending the digital signature creation, the algorithm will create the private key. It can generate and verify the digital signature, and then it reaches the recipient. So you will have one private key, and your recipient will have another key to utilize that and make it as a plain text. So here, as we have seen, the sender, here we have the sender and the recipient. You are sending a digital creation that becomes verification if it goes to your recipient. Recipient will access based on the verification. Here you are creating, recipient just verify the key which you have. There are two different, one is private key, another public key. So here is the calculate hash code and then encryption. So these both will become your hash code. So when you're calculating, that becomes your hash code that is equal to a public key of sender. So there are few benefits. It's commonly used. Authentication. So digital signature is authenticated for the message, source of message. Okay. So for example, some bank branch office sends the instructions to their central office in change what is the balance. So if the central office is not convinced, then the message is truly sent from the authorized source. So to avoid the mistakes, they also use the different encryption methods. So integrity, sender and the receiver of the message may be in need of confidence that the message has not been alert. So there is possibilities of the changes in the encryptions without understanding it.